This will be just a quick video to explain the procedure for finding the mean and standard deviation for a binomial random variable. So you may recall that for just generally for a discrete random variable, to find the mean, we take the product of our each value of the random variable and its probability, and then you have to add those up. So the formula is the sum of x times p of x. For a binomial random variable, there's a shortcut. We can just take n times p. So, for instance, if you are going to take a sample of, size 10, and you know that generally speaking, there's a say a 60% chance of success. So that's n equals 10 and p equals 60. Well, if 60% are successes and you do something 10 times, you would expect 60% of those 10, or n times p, 10 times 0.60, that's 6 successes. This is, of course, also can be referred to as expected value. Now, of course, that doesn't mean that you would, in in 10 trials, that you're always going to get exactly 6 successes. But that means if you conduct 10 trials over and over and over again, and then look at how many successes that you get, that the average in the long run would be 6. So hand in hand with this measure of center, we'd like to have a measure of how spread out the results are. So that's our standard deviation. And for a binomial random variable, we can take n times p times 1 minus p. And this will give us the standard deviation. So using these same numbers, I could take the square root of 10 times 0.6 times 0.4. So this is 1 minus 0.6. So that would be, let's see, 0.6 times 0.4 times 10. And then the square root of that is about 1.55. So this is the typical number of successes in 10 trials, but this is the results will vary, and this is a typical deviation from this mean. So that is how we compute the mean and standard deviation when we have a binomial random variable.